Hello, Internet. Good afternoon, good evening. I hope it's not morning for you because it'll be way too early for whichever part of the world that you are in. Yeah, welcome back to Coded Live. I'm Sam, your host, and I have my good friend Chris with me today. Chris, how are you, sir?
I'm doing wonderful. How are you?
I'm holding on. So this is a slightly different show because you're not going to see me struggle with coding that none of my stuff compiles and everything breaks all over the place. This is a little bit more polished because you're in good hands with Chris today. But this is a user group meeting, so we try to get folks together who are passionate about what they work on, what they want to talk about. So here is Chris. So Chris is here to talk about game design, but before we give it to him, I got a little bit of housekeeping to do. So let's see if tech works with me today. Move some windows around, and I'm going to share my screen, entire screen. That, go away, hide. There you go. Okay, now you can see my screen. And let's go full screen on this a little bit. All right, cool. So welcome, folks. Welcome to, well, let's tell you what you're being welcome to do. It is this. And I don't know, Chris, if I ever told you this, and I've known Chris for years here. Here's a quick history of how things have evolved and how much we have failed over the years. But no, it's all fun. This group particularly started way back in like 2008 timeframe when Windows Phone was a thing. So we called ourselves Central Ohio Windows Phone, a user group, and it went strong for a couple of years. Then we're like, okay, it's essentially Windows now. It's all universal, so let's call it Windows Dev User Group. And then we started getting more and more, JavaScript talks and AR, VR, and voice. And we're like, okay, app dev, Columbus app dev. It's pretty generic, right? And then the pandemic happened, and we're like, okay, we're not really meeting in person. We are virtual. Let's just call it global. And like saying, unless we go to Mars and we settle down, I think we're okay with this name. Hopefully for the immediate future. So we are the Global App Dev User Group. Tell your friends about us. We are right here every third Mondays. Normally, not this week. And Chris was very accommodating because next week, Chris and me actually both tied up at an event that Microsoft is hosting. So we are going a week ahead of time this time. But we are on Meetup, we are on Twitter, and we meet right here on Twitch every third Monday. All right, so that's about us. We do have a few folks who support us, who give us the tech, who give us the platform, and give us some discounted tickets to some shows. So thank you to our sponsors. Speaking of, so we are still, we are global, but we still have our heart and soul in, Ohio, which is where we started. So we always try to go over some of the regional events that we have coming up in the next, 2 months or so. Mostly in the U.S. heartland. We'll sometimes talk about, bigger shows as well. But this is what I could see coming up, and Chris, fill me in if I'm missing anything. Later this month, in late April, we have Connect AHA, which is coming up in Omaha, Nebraska. One-day conference, but good set of speakers. Should be fun. Then Star Trek is coming up early May. This is always a show that aligns with the big summer Marvel release, and I think it's the Guardians of the Galaxy. I don't know exactly what it's called, but Volume 3.
Guardians of the Galaxy 3. I don't know exactly what the subtitle is.
Yeah. But Chris will be there. And it's a great show, a lot of good speakers, and it happens at a movie theater. So you take in all the tech content for a day, and then you get to watch, the Marvel movie with your fellow geeks. So it's always a fun time. So if you're around Columbus, around in the U.S. heartland, consider coming to Star Trek. It's a great show. All right, looking ahead. So what's coming up later on in May and June? I'm not going into July, but we do actually partner with Visual Studio Live. These folks put on big shows all throughout the country. And the next one that's coming up is actually in Nashville. So kind of maybe closer to, the southern part of the country. Chris is from Huntsville, Alabama, so we are coming a little south, not as south maybe as he is, but this is, Nashville. They have never actually done a show in Nashville, so I'm excited to get down there. Again, this is a full week show, 2 days of workshops before, 1 day after, and then like 3 days of content. So if you want to go to one of these, you get a big discount if you, come as a user group member. All right, and then going into early, well, actually, kind of late June, we have KCDC, which is Kansas City Developer Conference. The slide is too dark because that's their website. So, anyways, that's coming up end of June or third week of June. Chris, anything else I'm missing between now and June?
Yeah, a little south of you guys, but in what's the name of that city? Chattanooga. I'm going to be at Scenic City Summit, which is beginning of June. So we might as well do a quick shout out to those guys.
I should have brought that up. Let's find out. So when is that?
I think it's first weekend of June.
And this is back to Chattanooga because again, Chris and me are a little old. We used to have this thing called Dev Link, right? That used to happen in the Chattanooga.
Yep.
Yeah. Now, so I'm glad to see something back in Chattanooga. Because Scenic City, was it always in Chattanooga, or was it somewhere else?
Scenic City was always, because that's where the Scenic City comes from.
Yeah. Okay. Yeah, I'm. There are a few things that go on in Tennessee because there's the TDEV conference. There is one more thing that is not in Chattanooga that I'm completely blanking out on. There's one more conference that goes on. Two more. Okay. Do you know which ones?
Up in Knoxville, there's Codestock, which is taking a year off, but they normally exist. And then I've heard Music City Summit, Music City,
exactly.
So they don't have a announced date or anything yet, but just from me knowing the people involved, they are trying to get something going back here very soon.
Yep. So this was that sounds like Sales Summit. This doesn't sound like. Maybe is it? No, that's not us at all. Maybe they don't have their website up for this year. Maybe like Chris said, they're considering something. But great shows if you're around Tennessee. And then Chris puts on a show of his own and has a team that puts it together. This is. Do you have a website up yet?
Last year's we have a website from last year, so it's devspaceconf.com. There's nothing new on it yet. We need to put our deposit down to make sure we have our dates firm and have like one more internal meeting before we're ready to announce stuff. But be looking for it in the next couple weeks.
Yeah, and this is always towards late fall. Looks like September, October timeframe.
Yeah, last year we did early September. Basically, we had to move it forward. We did October originally, and then we realized we were in Alabama during football season, so we pushed forward a little bit. But with some of the other ones kind of saying they're going to take a year off, we may push back a little later and then just move out of the weekend. So
sure. Yeah, sounds good. All right. So yeah, lots of things happening if you are in the developer space and you want to go do some shows. So without any further ado, let's welcome back Chris again. Chris is just awesome, all around swell guy. Long-term speaker, author, streamer, architect, MVP, all the things. And he's got this great session on game design, which I think I've got, some parts of it, not the whole thing. So I'm looking forward to myself.
Yeah. So, ironically enough, you talked about how this started as a Windows Phone meetup. One of the original versions of this talk was actually writing a game for Windows Phone.
Oh, there you go.
And it has evolved to be a pure architecture type over the years, just because so many platforms have come and gone. I'm like, look, here's just what you need.
Right. Yeah. All right. So that's it then from me. And I'm going to stop and bring up your screen, and the floor is yours.
All right. Well, thank you very much. And welcome to everybody out there in the Twitch lands and all the other lands that you're at. Thank you for joining us today. As Sam said, my name's Chris Gardner. Let's see if I can be on the right screen. I'm the chairman of DevSpace, like we talked about. I'm Microsoft MVP, like you talked about. I'm a Telerik Ninja. I'm also a senior products and services manager at Accenture. That's fancy big company speak for I'm a principal consultant. So I'm a guy who writes code and helps solve problems all day, just like everybody else. But on top of that, there's always the fun stuff we do outside of it. And years and years and years ago, I got interested in game design, and just kind of like the genesis of this talk was back in the days of the Xbox 360. I have one of them right up there. There was a wonderful program where you could actually write programs or write games using C# onto the Xbox 360 using XNA. And so I did talks based on that. And then they moved XNA to Windows Phone, and I did talks based on that. And lots of tinkering and playing around in my free time and kind of doing all the research and figuring out what works and what doesn't. And I'm like, hey, other people are interested in this, so let's give them the tools they need to tinker around and kind of show that a little bit of knowledge is what you need. The language doesn't really matter, any of that other stuff. It's just, do you know the correct techniques for how modern games are put together? And then from there, yes, XNA was awesome. And then from there, we can, other people can go and, yep, XNA does go to monogame. I occasionally on stream, and my Twitch streams are coming back here very soon, but occasionally on streams, I play around in mono game still, and we're working on a game as I have time to fit it into the schedule in mono game live. So if you ever want to do that, just keep an eye out on my Twitch, which we'll get to those links at the end. As far as the roadmap of what we're going to talk about today, first, we're going to talk about just some of the generic tools you can use. And, we've mentioned one of them, monogame, but we'll talk about every type of one you can use. After that, we're going to talk about some of the input methods, because believe it or not, knowing how the people are going to control the game sometimes can better help you decide what you want to do. So that's why we want to talk about that first, because if you have an understanding of how people are interacting with it, sometimes other choices make more sense. But from there, we're going to go into some of the design fundamentals and then talk about how to break those things up into manageable pieces, and then kind of how all of it should come together. And at any point in time, stop, ask me questions, all that other stuff. So what are some of the tools you could use? So in game development, there is no golden hammer, no matter what Jumpman there has, because Mario in Donkey Kong was Jumpman, not Mario. So that's why I called him Jumpman. But yeah, there's no golden hammer. So you can write things from scratch. If you are 100% your 343 Industries and you're writing Halo, you have a custom engine you built from the ground up. Nobody else does that anymore, though, because there's no reason to. So generally, you'll use at least some sort of tooling or framework. So that's that first step. So you can use engine-based tools, and these are very down-to-earth, easy ones to use. A lot of them have free trials. I mean, I put Scratch on there, and you may sticker, oh, that's the one to help kids with drag and drop interfaces learn how to, be able to freely make stuff. Yes, but on top of that, Scratch was also made to was invented to make very rudimentary games, because that's what interested kids. So if you just want to learn how to put the pieces together, as far as this type of loop is a game loop, and we'll talk about that later and everything, Scratch may be a good place just to kind of be like, how do these pieces come together? These other ones on here, Click Team, Construct, Game Maker Studio, all of those are just, you can go get them, download them. There's other ones, RPG Maker, stuff like that. They're smaller, less functional engines, but if you just have a basic idea and don't want to get into the weeds of the game loop and all of those type of development structures, they take 90% of that away from you, automate it in the background, and you can just worry about your content. So it's a great way to learn fundamentals. And some of these things have been used for very complex projects. The reason I added Click Team in there, which is one of the lesser known out of these engine-based tools, is there's this little game you may have heard of called Five Nights at Freddy's, and it was made in Click Team. So, I mean, you can do very impressive things with some of these cheaper and more accessible tools.
Chris, quick
Yes.
question. I actually did not know that Scratch lets you do that. That's pretty cool. Because our kid is 7.5, and I've been wanting to get him into Scratch. And do you find like kids get onto these things a little easier? Like they're interested in this with tools like these?
Of course, it always depends on the kids.
Yeah.
I have often said the things that make somebody a good programmer has nothing to do with programming. If you have kids with the right mindset, younger you get them, where that intellectual curiosity of you can and can't do this gets out of the way, then yes, it will help. But again, there's that piece of programming, which is, can you break a problem down into smaller problems? And some people just don't naturally have that. And I found that some kids who just literally can't have that, where you have to give step-by-step instructions to, they just become frustrated with it and throw it away. So it's a kind of yes and no on that one. But again, it was made to teach simple programming, and they do that in a way that's teaching games. So it is a great way to be like, hey, if you can say these are the steps to interact with this, and they don't know they're doing right and wrong at the time, and Scratch doesn't let them do anything too wrong, it can be a great way to pick up those principles for anybody. That was a really good question, though. Thank you, sir. There are more complex tools. These are the three big ones everyone's heard of: Unity, CryEngine, and Unreal. All three of these, which are very nice, have the fact that there are free versions of them you can use without having to spend any money. At least last time I checked. This changes all the time. Unreal recently went to a model where they are 100% free until you make a certain amount of money off your game. Then you owe them a royalty cap, and it's something like $10,000. If I make $10,000 on my game, you can have 15% because I'm doing okay at that point. It's the way I look at it. Unity, 100% free version. The way they do it is the base Unity for PC, I believe, is free. And if you want to cross compile to other things like to a console or to the web or to mobile, you have to pay for the cross compile feature. So you're only paying for the pieces you're actively using during publishing. And CryEngine, I think, has a free trial. I think you're not allowed to publish without a license, but I think there's a version you can download to play around with. These are tools the pros are using. I mean, even Unity, as much as we say it's all used in indie game design, there are plenty of professional shops that are using it too, because the line between indie and AAA studio is starting to get blurred more and more as you get indie developers making AAA-like experiences because they're doing it in the evening for 5 years and waiting to announce it until they're ready to go. So plenty of people are doing that. And of course, there's also all the raw tools. You can use DirectX. You can use OpenGL. You can use, as a raw tool, something like Monogame or any of those parts where really you're not getting the engine for free, even though Monogame, you get that much of the engine for free. And you're really starting everything from scratch from raw code. All of those tools exist. It just depends on how deep down into it you want to go. And typically I have found when I talk to people, they'll start at a tool and go more and more low level as they kind of I don't want to say finish that tool, but kind of their interests and what they want to do are no longer capable in there. So they'll start in something like Game Maker Studio, and then they'll hit a point where it's like, well, I want to be able to do this and I can't do it. So now I'll move over to Unity. And then from there, they may go, hey, I need more control. And they'll start adding tools and they say, well, now I'm going to drop it down to this toolkit. Or some people just like to start some people just like to say, I like to have control and tinker and be low level and build my way up. And I first experimented in DirectX, which was painful. If you don't know C# or C++ like the back of your hand, it's very painful. But then moved up to X and A and kind of lived in that world where very little was done for you and you had to move up. So it's just the speed you want to look for. And these tools exist for just about every language. So don't think you have to be locked into C# or anything like that. I've seen development tools in Ruby, which ironically is about the only language I would tell somebody not to release a language in or release a game in, because the Ruby engine is notoriously non-performant. But learn on Ruby if that's your language you're comfortable with. 100%. It's all about learning the tools, and then when you need the more performance, you start porting things over to where that performance needs to be. Any questions about tools and stuff before we move on?
Yeah, I was telling Chris before we started, like I'm the annoying sidekick who has plenty of dumb questions. So maybe you get to this, but here's me as an old man with years of dev experience. But this is what is the big stumbling block for me. And when you talk about raw tools, like you're talking about engine and the features of the game. But the graphics part of it is the big challenge. Like, I mean, how do you even make things look decent? So are you going to talk about any tools that you use?
Well, I don't normally talk the hardcore, like how do you make a good sprite sheet or how do you make a good 3D model? Because what you do is you make a very bad one to place into your world because you're not an artist. And then when you get better, and this is a good thing that that's not explicitly in here, but I'll mention it. you go to the Unity asset store and you buy good 3D models that you then put in place afterwards. Or you go to Fiverr and you pay somebody $50 to create you a custom. That's how you do that.
Yeah.
I am no artist. Any of mine look horrible until I go find a buddy that's an artist and say, hey, I need 30 sprites that look like asteroids that I can rotate and move around. And they're like, okay, here's 20. You know, that's the way I do it. A while ago, Apple was big on releasing Metal and trying to make OpenGL operations. People shift to Vulkan or still use OpenGL. People should use whatever they're comfortable with.
Okay, what is Vulkan? I have no idea what Vulkan is.
The beauty of using something like Vulkan or something like OpenGL, I mean, is that it works everywhere. Just about. I mean, it will work on Linux. There are versions of it that will work on mobile, on SoC chips, all that other stuff. Vulkan is still very much Apple. If Vulkan's what I'm thinking of, which is basically what
they did after Metal,
then you know, if you want to get low level on a Mac and their custom silicon, yes, that's what you're going to need to do. But the beauty of OpenGL, for as much as it's horrible, is that it works everywhere because it is just it is the POSIX of graphics. That's the best way to put it, you know.
Yeah, I think this is the one that's been talked about. It's nice. It's got Windows, Linux, Android, Switch, Nintendo support. Yeah.
Cool. I will definitely check that out after this. All right. Well, let's talk about inputs. And let's talk about not using Rob the Robot, because as much as he was fun, he was a horrible input. But what kind of inputs exist, right? When you think of your inputs, I generally like to say, don't think about controller or don't think about PC. Think about what the individual types of controls are, because from there you can really determine how things need to be put together. And so by that criteria, I like to break inputs down into 4 categories that you need to consider, which is digital inputs, analog inputs, natural inputs, or network inputs. If you're talking about a controller, you're mostly talking about digital inputs, except for the couple analog sticks and triggers and whatnot. If you're talking about analog, that's a lot of mouse, things like that. We're going to go into more specifics in a moment. But just kind of knowing how people are going to control it and how they're going to interact with it will very much determine what you can do. So if you've got a digital input, like keyboards, or if you're dealing with mouse, like the buttons or the scroll wheels, if you've got the scroll wheel that's clicky, so it's like click, 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 that's generally just an input. We went up on the scroll wheel, we went down on the scroll wheel. It's not using an offset. If you're talking about a controller and you got your buttons or your D-pads or whatever, those are digital inputs. They're down or they're up. That's all you got. If you're on a mobile device, a tap is just, hey, I registered a tap happened. You know, that's how some of these games where all you got to do is tap on beat or something work, is they're just taking that digital input of somebody tapped on the screen. These are all digital inputs. And from there, you literally only have the option of this button is down or this button is up. And if that's what you have and that's what you want to deal with, which makes it very easy to deal with some of the logic, that's going to control certain things you can do. If you're just doing a down or a up, maybe it's easier to lay things out on a grid and move a grid step at a time. And you can still do that in a fluid way that looks like it's natural and analog by, you know, scrolling the tiling of the world and whatnot. But really all you're doing is animated, you know, is digital inputs and moving a square at a time. And that's a lot easier to deal with, and there's no harm in that. For years, Pokemon games have basically lived on a grid up until, I think, Sun and Moon. I mean, relatively recently, before they got a full 3D and they weren't actually hiding the fact they were on a grid in the background. Or even using a combination therein. Super Mario Brothers, that's 100% a grid layout. It's just Mario just can happen to scroll naturally through it. So can everybody. So they're using subsets of pieces. But all these are just grid layouts, and they're tile layouts, and they're very easy to do, and you can do very impressive things with them once you know what you're doing. So that's your digital inputs. And normally in a game loop, we'll get to this in a moment, you literally pull them by, if you want to, you can say, hey, when it was not down and now it is down, do something. Or when it was down and it's now not down, do something, like on the key down or key up. They don't give you those, but generally you look for those edge cases when you're dealing with that type of input. Every game is different though. You've also got analog inputs. This is when you're dealing with the mouse. If you've got the scroll wheel that's squishy, sometimes those are, hey, I moved off axis this much. But definitely the movement. If you've never worked with a mouse at a low level, what it returns to the computer is, since the last time you asked me and I reported back to you, I've moved so much in the X and Y direction. And that's all you get back. And then you have to be able to take those inputs and say, okay, well, that means I need to move whatever is tied to that in that much of a squishy amount. And that's when you also add sensitivity. So I'm going to take that input level and multiply it by 5 or multiply it by 10. So when you get your first person shooters where you can fling yourself around like no tomorrow, that's where all that comes from. Excuse me. Same thing for controllers with the analog sticks and the triggers. You just get a X and Y position for the analog sticks. It's from 1 to -1 in the X direction, from -1 to 1 in the Y direction. Triggers is from 0 to 1, things like that. If you're dealing with the phone, sometimes touch can be, I dragged my finger, so it was like, since the last time you asked, it moved this much in the X and Y direction. They're just offsets. If you're going to be able to use those, you have to understand how to use them. You have to be able to either quantify them to what it needs to be for the digital world you're in, or you need to be able to say, we have to move at these kind of weird subsets, and how to scale that. Because if you're only getting a value from 0 and 1, trust me, as somebody who's written the game that does it, you don't want to move on the screen only by the coordinates that comes back from the stick, because it's dreadfully slow. You definitely want some sort of multiplier or sensitivity setting on that.
Chris, I have to ask, is this an actual mouse?
Yes, that is a mouse called a rat, as it says. As it says right here. I don't know if it's not presenting my.
Yeah, you can kind of read.
Yeah.
Wow, that's fancy.
Yeah, it was an old school gamer mouse back before it got standard that mice would have like all sorts of buttons and stuff on it. And it was highly configurable and you could move everything around. But now it's just, they put 800 buttons on a gamer mouse and nobody needs something that configurable anymore. I just love the way it looks, because it looks like it's this big. But yeah, that's a real product.
So what is your mouse of choice? Gotta ask. Oh, I've seen that. Yeah.
Yep. I don't. It's, what's it called? It's like the Blackadder Essential or something like that. I'm not a big mouse user. Like, even when I program, I learn hotkeys and try to avoid the mouse as much as possible, and I much more prefer analog. So I don't have a big scale gamer mouse, because even if I am going to play on a PC, I'm probably going to hook an Xbox controller to it.
Yeah.
But yeah, I've seen those crazy ones. My daughter is getting big into PC gaming, and she wants the fancy mechanical keyboard and the Uber gaming mouse. I'm like, but I avoid paying for those things for years. But yeah, it's coming.
Nice.
All right, we've also got our natural inputs. These are things like touch gestures. So knowing whether it was a swipe left or swipe right, knowing whether it was a swipe up or down. Back in the day with the Kinect, it was, you could do gesture-based things and it could know how things are moving. There was a item called I meant to pull it out. It's back in one of those boxes back there. Thing called Leap Motion, which is just a little tracker that lived under your monitor, so you could interact with things naturally, and it would use your hand. This now gets used a lot in VR. So it actually, you moving your head will cause the camera to move, and the little wands with the buttons also have motion trackers on them, so that they're actually tracking you like you're actually in the world. All of those are considered natural inputs, and you have to be able to deal with that kind of scale. I remember doing talks on the Kinect years ago and explaining, hey, the Kinect just tells you where 24 points in space are. You have to know that it thinks a hand is here and an elbow's here and a shoulder's here, and you have to decide what this means. All of those types of inputs weren't necessarily given to you. So if you're going to be dealing with something in that way, you have to understand that those have those limitations. And finally, the biggest one people don't think about as an input, but it really is network inputs. If you have online gaming and you're getting network input from somewhere else, you have to remember what's a good lag or good ping time these days.
I have no idea.
So 20 milliseconds is like the gold standard. If you can get a 20 millisecond ping, you're doing really well. Now, if the game's running at 60 frames per second, that means you're processing frames and local inputs faster than the network inputs are coming for the corresponding things. So there is guaranteed going to be a lag between the two. So if you're going to deal with online, how do you deal with the fact that I don't know what this other thing's doing until 3 frames after it's happened? Especially when you start getting to pro gamers who have moves and no timings down to the frame of animation. Now you're trying to put a network lag in on that. So there's all sorts of tricks for how to deal with that. A little later on, I believe, and if not, I'll just come back to it. I kind of go into some networking considerations a little more when we start talking about how the game world puts all the pieces together. So we'll go into more detail on this later. But I mean, other than that, those are your general inputs. Any questions as far as that stuff goes?
No, but like you said, like the natural thing, that just has so much of complexity to figure out what it is that you're doing.
Yes. Yeah, weren't Ed and Alyssa trying to do a VR game for a while?
Yeah.
It's
not easy.
Yeah. All right, well, wrong way. Let's start talking about some game design fundamentals. How do you put all these pieces together, right? So I've already spoken a couple of times about what is known as the game loop. This is the most simple game loop I've ever seen. Having said that, this was also XNA's game loop. Coincidence? Maybe not. But the general way a game works is that you do some initialization. The initialization is the same thing you would do when you start a program. Think about you writing a command line app. You just get a few inputs and you have to start everything else from there. Same idea. That's initialized. Load content is typically when you actually take assets, whether they be sound assets, video assets, any of that other stuff, and you load them off the disk into necessary places. So it could be sending your textures and your vertex data, 3D objects, everything, and preloading them on the video card so that you're not trying to send them every frame. Say, hey, here's stuff you're going to use. It could be taking sound clips and preloading them into memory for the sound card. If you need to open a network connection, that's where you open that connection, make sure it's stable before you begin. This is where you load all that kind of external stuff. You then get into the game loop proper, which is you'll do an update, which is you'll take the game world and you'll do everything you need to update it from one frame to the next frame. Everything. Your entire program lives in update. And we've all written that program that was one function that was 800 lines long that did the same thing. Well, this is that one function which is 8,000 lines long that runs the entire game. That's what update is. Then you get into draw, which is where you take the state of the world after updated everything, and you say, now draw this to the screen. The way this generally happens is using a trick called swapping that most modern video cards know how to deal with, which is there's what's on the screen, and that's called the front buffer. What you do is you fill this other secondary buffer, which is called the back buffer, which is what you would like the screen to look like. And then instead of it trying to delete things off the front buffer and add things and getting all that weird screen tearing and whatnot, it literally just says you have the back buffer where you want to display it. Well, we're going to swap a pointer between the two buffers. So now the monitor is getting the completely rendered output from the back buffer. And the back buffer becomes the front buffer, and the front buffer becomes the back buffer, and then you just do everything. And it just swaps back and forth. But that's generally what draw does. It just updates whatever the world does. And then it goes back and asks for the next world update. And that loop, if you're doing 60 frames a second, is like what? 0.16, or it's like 16 milliseconds, I think is how long you have for that. That may be for, that's for 60 frames a second. Or is that for 30 frames a second? Anyways, it's happening really fast for every iteration through. When you're done, if the game successfully exits, you then go to unload content, where you tell it to remove all the stuff from the video card and remove all those other assets, close your network connections, and you leave. Of course, when you're first doing this, it's more likely that the game's going to crash, and then all that stuff gets unloaded anyways, but details, doesn't matter, right? That's your general architecture. That's what's going to happen. Even when we break this into smaller things, this is always happening. We're just taking code outside of update and moving into other places so it can become more manageable. We're taking code in draw and moving into other places so it can be more manageable. But that's your general architecture. A fun fact, speaking of app dev, if any of you were WPF devs, WPF ran on a game loop. And because of that, you actually could do things like directly address draw inside WPF. That's what that whole what was the name of the protected thread? Sam, do you remember?
Mm-mm.
But there was that one thread that you couldn't touch, or that couldn't change data, and then everything else could change data but couldn't touch the screen. That was the draw portion of the game loop. And you could even write shaders that went on top of that draw command to do all the funky stuff. I mean, WPF was just running a game loop, and they exposed it if you knew where to look for it. So you've dealt with this stuff before.
Okay, I got one comment and a question.
All right.
The comment is, it's interesting how you talked about the buffer front and the back and how to swap it. Because you started talking about it, and I immediately went to how some of the model view update patterns work. How React, or even like Blazor to an extent works. So they do what's called like a diffing. So they don't paint the whole visual tree. They're trying to watch like in the next buffer, like what has changed, and they will just literally just swap out the things that have changed and not do the whole thing. But here you're saying it's almost like server side rendering. You already have a pre-rendered frame. You're just like swapping it out.
Yeah.
So that I thought was interesting. And do all games work this way? And most game engines do this? Like the way the buffers work?
Yes, because that's the way most video cards work.
Okay.
Of course, for a certain proprietary piece of software or hardware, it may do something different. But all video cards, yes, you can get direct access to the front buffer, but it's already built in for, here's the front buffer, do everything to the back buffer, and then we'll just do the swap.
Yeah.
And it does it for you. You don't even have to think about it.
Sure. Yeah.
So, and literally, if you don't change the back buffer, it will, and it does the swap, nothing will look changed. So it'll do that way. So, and if you start talking about games that have like variable frame rates and whatnot, or mobile phones that have variable frame rates, where it's like, oh, well, we'll go up to 120 hertz, but if you're not doing anything, we'll stay at 1 hertz. That's literally, they're saying, hey, the back buffer didn't change, so I don't actually have to update anything.
Mm-hmm. Yeah. Okay. And also, you mentioned, the FPS 3060. These things are happening really fast, right? So, are there any guardrails in place for whichever programming language or tool or engine that you're on that protects you from trying to do too many things, where it starts complaining that I might not be able to finish that update loop?
So, yes, one, if you don't have a locked frame, if you have a locked frame rate, draw will draw whether you're ready for it or not. And it will just wait for the next update to be completed before. But that's how you'll get really weird tearing. And you'll see game engines that say write your most important code first, because if it gets to the point where we're ready to draw the frame and you're not done, you're only going to get to that part, and then we're going to cancel your update and start a new one. So that's where that comes from, where you see like things in the background stop moving. That's where that comes in. On top of that, you can, certain game engines, XNA has this built in, so Monogame has it built in. There's a flag you can check. There's a object that gets passed back and forth between update and draw. I don't remember the name of it off the top of my head. I think it's called game time or something like that. but there's a flag in it called game running slow or something like that. It's a very obvious flag, but that's a flag that gets thrown anytime it was time to update draw, but you hadn't finished update yet, or it's time to run draw, but you hadn't finished update yet. So it had to skip a frame. So the next time you go through, you can say, hey, things are getting hectic. I may want to skip certain parts to get back to where I need to be.
Yep, makes sense.
That's a good question, though. All right, well, let's talk about components, right? So what's a component? I don't think I have to ask the person at Telerik what a component is. You kind of made your business off of it. But components in games are the same thing, and they can be external widgets. Again, you can go to Unity, you can go to Unreal. They have asset stores. You can just say, hey, I need this component, pull it down. It's already written for you. You can write your own component saying, hey, I've got this thing that I'm going to use a bunch of. I need to write it once, just like any other widget, and we'll just bring in new instantiations as we go along. They're components. So what can you do with a component? Generally, game components have one of two things about them. They can either be a full-blown component where they're modeling something that will exist in the world. So the component itself may or may not run on a separate thread. Like, let's say it's AI enemy logic. You may want it running on a separate thread. So it's observing what's going on and deciding what to do. Or it may be something that gets updated with the world, so it's running within the main game loop. But it can have its own update. So it says, hey, when the world's in this game state, this is what I do. If it's a block on the ground, what it's going to do is nothing. It's a block. It's going to sit there, right? That's what it's going to do. But then when you're in camera, you need to be able to draw yourself. So it may say, here's how I draw myself in the world. Here's what I look like. Here's how I will render. Here's based on all that other stuff. So the game component itself can have its own game loop where it's doing update and draw. Generally, what happens is it will update itself on the timer it's given. And then when it's time to draw, the main draw engine will say, I need your information for how you need to be drawn. Based on Z order and all that other stuff. It will ask it to draw it, but it'll keep running by itself. It may be something that's just keeping track of some sort of internal component. Like, let's say it just reads the real-time clock and takes that clock data and turns it into a modified scaled game time. Just because I'm looking at it right now to give you an example of that. Looking at my Nintendo Switch, I've been playing Pokemon Violet. It runs a game world clock that takes 72 minutes to do a full one-day game cycle. You get 36 minutes of daytime, 36 minutes of nighttime. It actually synchronizes it off of the real world clock. So if you change your game clock, it can suddenly become night. And you can look online at a table that says, if it's this time of the day, this is what time is going to be in game. That could just be a game component that runs an update that says, check the system clock. This is what time it is in the world now. The rest of the world can respond to that. So that's something that doesn't necessarily need its own draw. It's just updating a piece of information that the game's going to need. Right? So if you've got all these game components now, and you're not doing it within my big 800,000 line update function, how do we know what should do what? Right? So the way I like to say the separation of concerns for what does what is a game component should be very self-centered. It should do whatever it wants. It should take the input it's given, much like just any sort of state machine or anything like that. It takes the input it's given and says, given this input, this is what I do. Whether or not randomization is involved with it or not, right? You may pull a random number out because it moves a random number of spaces, whatever. But it does whatever it wants. So the game world kind of comes in and says, here's the state. We need to update everything. Game components based on the world right now. What do you want to do? And all the game components go out and run, and they can run in different threads, and they can run on different processors and take advantage of multi-threading. And they all come back and they say, this is what we want to do. And then the world kind of comes back and goes, you can't do that. I need to clean this up. You can't do that. I need to clean this up. You're good. You're good. And it kind of puts all those pieces back together to maintain the consistency of the world. And then once everything's moved, it then deals with all the interactions. So that's generally how I deal with that. So that, yeah, that's my suggested order on that. Is the world updates the world. The world tells everything else to update itself, and then the world fixes the consistency within whatever the game components wanted to do. And then once all that's done, it tells it to draw the state of the world, keep repeating. That's all it is.
Yeah, you make it sound simple, but it's not, right?
Right. I mean, it's just as simple as if you're handling input coming in from any other line of business app. It's happening a little faster and a lot more
Sure.
of them.
Yeah. No, well, I mean, where my mind immediately went down the rabbit hole that, once you have all of these components doing their own thing on different threads, and then you're trying to bring it all together into an update loop, that's the, master loop of the world that you're trying to paint. I mean, you could have things go off sync if you're not careful, or if the timing of things doesn't work out, because it's going to get complicated, right? If everybody is doing their own thing on their different threads, how does that work for the whole gaming world?
Threads, games and threads have a very complicated history. If you actually look in a lot of modern game development, they don't use they're only now starting to use threads, and they're starting to do a lot of thread locks, and the fact that says all of you things go out and do your independent decisions, but I'm not doing anything till all of you come back and conclude. And if you don't get back in time, you just don't get to update, and I'm going to ignore you until next time. Because you're right, it really does break the flow of the world and the way all these things are happening. So a lot of times, like with the original Xbox 360 and the original XNA, there was this really evil thing where even if you started threads and told them to run independently, all threads ran on the same processor and just basically became blocking calls unless you specifically told the thread after you started it to move to a separate processor. And you had to manually assign processors, which was completely insane, but it brought home the fact that if you're telling this to go off and do something separate, you have no guarantee in the timing of it or how it's going to affect the world or whether or not it's ever going to return. So it was kind of their way of saying, if I tell this task or this component to go run on processor 2, which would have ended up being the first physical process or the first virtual processor on the second physical core, but go run on processor 2, that might as well have been a fire and forget. But it was really useful if you're doing things like updating stars twinkling in the background, because who cares whether or not it came back in time? So it was kind of picking your battles on that. But I mean, even if you think about it now, I can't think of the last time I've seen a computer with a single core in it. Having said that, game designers, they have minimum specs, and they say things like, okay, they may say you need to have an i4 with 4 processors. They can't assume you have a 16 core machine and they have access to all those cores. So they're probably not even using everything that you can throw at it. Welcome to writing PC games where there's literally no identical configurations. But I mean, with web browsers, you don't know what version of the web browser they're running or which web browser it is. I worked for a company once where they had this big, huge way they validated things that went to the App Store, and it was this long, complicated process. And then they had how we updated the website, and it was throw it on the website, because if we put it on the website, we could easily tear it down if there was a problem, and it would update for everybody. Once you send something to an app store, there's no way you can guarantee anybody will ever update it ever again. So it had to go through more validation. Same thing with games, right? You've got that kind of hard lock. All right, let's talk about the world. If you don't have another question.
Yeah, I'm good. But
Yep.
All good points here.
Yep. So what should the world do? Quite plain and simply. First thing and foremost, the world should take care of time. The world needs to run the game clock, right? No, even if you're doing something crazy like in Braid, where it's a game mechanic where you can rewrite time, fast forward time, game does weird things. That still should all be controlled by a central thing in the world. The world says this is the time we're running off of. Here's what's going on. No ifs, ands, or buts. If a individual character cares about the time, let's say at nighttime stats drop, etc., it asks the world tells the player, it's this time, make that as part of your input. Furthermore, this game clock should be responsible of keeping track of when events should happen when you start getting to like timed events and stuff. We'll get a little more into that later. But like, let's say you're doing a game, an asteroid style game, asteroids are coming in. How often do you spawn them? The game timer of the world is what says this much time has elapsed. You should start a new one. Let's start a new timer to wait for the next asteroid. All of that should be part of the world. One place, much like in real life, time moves on whether or not your clock says it's correct or not. I was reading a great quote the other day. I loved it. That said, nobody knows what time it is. It's just what time we all agree it is based on the clocks we have on hand. That's how that works. So the world controls the clock, whether you like it or not. World should be in charge of physics, right? And it doesn't have to be real world physics. Mario does not use real world physics. I think they figured out some people who have done like counting pixels based on height and jump and whatever, and what we know Mario's height is. In Mario, the gravity rate was something like 23 meters per second, or maybe even 29 meters per second, not 9.8. And that Mario was just stupid strong to be able to jump that high. But based on the gravity rate, that, how fast he goes up and how fast he goes down, that was the size of gravity. But all these physics need to be the rules for, what, just like what we think of as physics in the real world. They're the rules that model what goes on in the universe. You get to create those own. You can pull out a physics engine like Havoc. If you read the credits of almost any game, 90% of them you're going to see use the Havoc engine, because that's the engine that models real world physics that's nice and plug intoable into a game where you can say, here are my physical constants for the world. Now just apply it all to all the objects and make it work, right? So there are, but you can create your own physics engines. Think about them writing Mario back in the day in assembly for an 8-bit processor. They had all their own physics. And that jump is just what was natural and made sense. They carried it forward until now. Mario, the Mushroom Kingdom, has 23 meters per second for gravity rate. But you got physics.
Have you seen the new movie?
Seen the Minion movie?
No, the new Mario movie.
Oh, no, not yet.
Yeah, I haven't either. But
over the weekend, I was DJing a wedding, so kind of
cool.
everything got pushed off for that.
Is this physics thing like what we say, like for authentication, authorization, like don't do it yourself type of a thing?
Don't do it yourself for the sake of doing it for yourself.
I see.
There are times where real world physics may not make sense for what you're doing. And you may want to write a piece that says, no, I need to deal with this kind of weird special gravity. But for the most part, if you've got the money, or I think there's a free version of Havoc if you just want to play around with it, throw something else at physics. You really don't want to worry about it unless you just need something that small. So speaking of asteroids, I wrote a little game, which used to be the demo game when I did the Windows Phone version of this talk, where asteroids would fall from the top of the screen, and you would shoot them as a ship, but if it hits you, you'd blow up. Very simple game, type of thing I could write in an hour during a talk after I'd practiced it for 2 years straight. But at one point in time, I wanted to we need to release this to the App Store. And I got 87% there before Windows Phone got deprecated. But anyways, at one point in time, I'm like, we don't need physics. I just have it falling from the top of the screen. It picks a random rate because it's speed. We're technically in a zero gravity environment anyways. It's just these things falling. But I wanted to add in the nice touch that if two asteroids hit each other, they would bounce off each other. And they'd bounce off each other at correct vectors. I don't want to... I'm embarrassed how long it took for me to implement that. Don't write your own physics if you don't have to. For game size and the fact that that was all I needed, okay, I did it. But take it from me, that took an embarrassingly long amount of time. And I have a degree in math, and I know vector math, and it still took an embarrassing long period of time. So yes, you can do it. Don't do it. You either need no physics and you just need simple. It's going to go up 3 pixels, down 3 pixels, or use a physics engine. Really. How about controlling the camera? I love this picture. It was from Super Mario 64. It was the best explanation of how the camera in every first-person game works ever. In Super Mario 64, they made it a feature where Latku had a camera on a fishing pole and was behind Mario, so that when the camera did really weird things, it's because Latku couldn't go through the wall either. And if you found the mirror in the castle, you could actually see him because he was always there, which is where this picture comes from. This is still what gets used today. If you've got a good system, as you like back up against the wall and the camera's behind you, it will shift accordingly within the game rule. If you get those bad games or those low quality games you sometimes see, you back up and all of a sudden the camera's through an object and you're seeing the inside of an object, you can't see anything. But that's because the camera is a physical object in the world. Because of this, it's generally, even though the player may be directly controlling it, the world should really take control of the camera, because based on the direction it's pointing and the angle it's pointing at, it can see what the camera should see. And since it sends the data to draw to know what to draw, it can say, hey, I don't even need to send this information to draw. It's behind the camera. It's never going to be seen. And then, here are the objects you actually need to draw because they're in the camera's view. And then you kind of let the graphics card figure out occlusion and all that other stuff. But that's kind of why the world needs to be in control of the camera, because if the camera just goes wherever it wants, even if it's user controlled, bad things can happen. It needs to worry about the state, right? So as it's going along, it needs to, every time, it needs to control the inputs, know where those inputs need to go, to what objects. It needs to, generally speaking, because of digital inputs, it needs to know what the last state was so it can compare it against the current state. If you only want something to happen on button down or button up, like if you're charging something and then on the release, you have to know when that trigger state happens, right? You can filter your objects based on whether or not a controller input, happened. All of these things. So the state of the world, which, kind of goes without saying, kind of comes into all of this as well. And I believe finally, you've got your game events, which is, like I said, would come from. There are 3 basic type of events you need to worry about. First one, we already talked about, timing-based events, right? I want to introduce an asteroid into the world every 30 seconds. So I'm going to use my game clock and keep my own timer and say, oh, new one happened. Let's spawn one in. Here's where we spawn it in. It's now its own game component, and it has its own free thought, but the world had to create it. It was nothing else that created it. You could have world-based events, things happening on a day or night cycle. Things happening because 2 objects collided, whether that be like with my asteroids and them hitting each other, and so me saying, oh, I now need to update based on this event in the world to make this happen through this interaction, and completely change like your motion vectors. Or my personal favorite, and I'm about to break games for anyone listening, position-based events. Hey, this needs to happen when you cross this point in the world. This was notorious for happening in games. And once you know about it, games become so much easier. You're running down the hallway and all of a sudden new enemies spawn. They spawn based on you passing a certain point. It's a lot easier if you're not looking at enemies, because there's enough confusion that happens with that. Think about, I'm going to go back to Halo. You beat the big arena. You cross some threshold. all of a sudden, everything clears up. Cortana starts talking to you because you walked past a certain point and you've kind of triggered the events of everything behind you is going to unload. Cortana is going to talk to you to distract you while you're moving forward and not noticing this hallway may be longer than physically would be possible in this game world. Spoiler, Halo uses hallways as loading zones, and you can confuse it if you try really hard. And then all of a sudden, when you walk forward, when it's done loading, you'll suddenly start to see the end of the tunnel, and you can get through it to the next area. And then Cortana will say something after that's loaded. And then as you walk forward, you can walk forward to a certain point and cause one of the enemies to spawn and then deal with him, and then take 2 more steps forward and cause the next one to spawn and just deal with that one. Instead of running headfirst into the middle, which hits every trigger, and 15 spawn at once. I have physically taken advantage of this. I think it was the Tomb Raider remake, so Tomb Raider Definitive Edition, where I kept jumping down this one place and 4 guys came out and I couldn't deal with them. So I said, okay, let's start applying game logic. And I walked over to the ledge and I kind of stuck 1 foot over, and then one guy jumped out. And then I backed up and was able to take my bow and deal with him. And then I kind of jumped down the ledge and kind of shimmied over to the edge, and another one jumped out. And I was able to take, and I kind of slowly hit those triggers because I know how the game designs work, and we're able to filter how many things I had to deal with at once. It's there, you just got to know to look for it. And of course, from some of this, you also have to deal with, hey, if I get a trigger from the network because something external happened as an event, generally at that point in time, you're dealing more with the network input, but you can have network-based events like, hey, I'm not actively network playing with somebody, but I did get a network event from a local place saying, like, let's say somebody wants you to join in their game or something. There could be some weird ones like that, but those are generally more exceptions to the rule. Pretty much that's it in a nutshell. What questions do you have?
All right. What's your engine of choice these days? Based on, I suppose it depends on what you're building, but have you used Unity extensively?
I have used it a little bit. Most of my interest in the type of games I've been playing around with and ideas I have work great in like a 2D sprite framework, which Monogame does very well. It eats that up for lunch. And I'm very comfortable with that framework, and I'm very comfortable with that engine. Having said that, there is no way I would want to go that low level if I was doing a 3D based game. And I would definitely move over to something like Unity, where you could actually just lay out the world and lay in the game components and let it do all the drawing and all the game loop and everything in the background for you, and let it just run the engine. So I'm still primarily using Monogame because of the type of things I like to tinker around with and the games I tinker around with. But yeah, there's no way I would do that for a 3D game. There's just way too much low level stuff to deal with as far as the sprite work, or not the sprite work, the 3D objects and whatnot. To prove points and to do certain experiments, I have manually created 3D meshes, and I swore I would never do it again after doing it.
So maybe I missed the internal details of what happened. So did Microsoft sell XNA, or did they acquire this? Like, how did Monogame have XNA?
Oh, okay, this is a fun story.
Okay.
And it involves lots of people we know. So,
all right.
Microsoft created XNA as this framework, which worked for creating games in C# for Windows PC and Xbox 360. Everybody loved XNA. XNA was an awesome framework. It was a great tool. It was the first accessible thing to the average Scratch programmer to really be able to make games and play around and tinker and do things. And it was a milestone in indie game development, right? Because it was the first tool that made things extremely accessible to everybody. It got so popular that people wanted to run it on other places. Well, there was this project you may have heard of called Mono, made by this guy we may know called Miguel.
Diakazo.
Yeah. So he created the Mono framework, which said, "Hey, we're going to create a compiler, or I'm sorry, not a compiler, a runtime for .NET that runs on other platforms."
Like Linux to start with.
Right. So the the XNA community said, "Hey, we love this idea. So let's create a framework called MonoGame, which uses Mono, and then we'll work with vendors to write the .NET runtime for other things such as the PlayStations and Nintendos and everything else, so that when people make their games in XNA, they can then compile them to other locations." And then Microsoft discontinued XNA, which had some problems in the fact that Monogame assumed certain tools from XNA existed. Now all of those tools, Monogame has their own version, like things like the content pipeline, the content compiler, things like that. Monogame wanted you to use XNA's version and then just port those files over. But anyways, Microsoft deprecated XNA, so then Monogame ported Monogame to Xbox and PC. So they actually took what they ported out of PC and then ported it back. And that's where we got to Monogame. And then along the way, they're like, "Oh, we still need a content pipeline. So go download a deprecated version of XNA and use theirs, and then copy the content pipeline files over." They now have their own, et cetera, et cetera. It's now fully fledged. But yeah, that was the back and forth. Is Microsoft built it purely for PC and
Xbox and
Xbox. Yeah. Other people ported it to other systems. Microsoft got rid of the original version. They ported it back.
Yeah. Good to know. Because, when you talk about Monogame, like the first thing that comes to my mind is like Mono Touch and Mono iOS and Mono Android. That's how how like all of these Mono things got started. And this was early days of .NET, where it was very closed source, and essentially like they looked at the distributables and C# ECMA standards to figure out and like reverse game to understand how .NET used to work. And now all of that is open source, so they could actually just go look at the source and figure out how that worked. So even if you're saying like XNA is gone, they could still make it now go back and make it work on PC and Xbox.
Yep.
Interesting. All right. What about the other aspects, like sounds or any type of explosions? Like all of those are also assets you can go buy, pretty much.
You can go buy them all. So just as much as you do graphics packs, you can do sound packs that are everything together. The way XNA used to do it is, and a lot of the other engines have the same thing. You can take individual pieces of sounds and put them together into packages. I believe the tool that did it in XNA was called Exact. It's the XNA audio something tool. Anyways, you could actually put in timings to where you would have multiple things go together. Like for a gunshot, you could have the trigger noise and the noise of the shell coming out and all of that, and it become a sound trigger. But then you could also say variably use one of these three sounds for the shell kicking out, variably use this exact sound for the gunshot, all these pieces, so that this was the sound trigger. When somebody said pull trigger on gun, it caused this thing to happen. It spawned the bullet. It caused this thing to happen amongst the world, and it triggered this audio event. And it then just became an audio event. You said, go tell the sound card to play this audio cue. But it would handle all that randomness. Most systems will have something like that in place, whether it either be you manually are saying, do this, wait 100 milliseconds, play this cue, and you can do that, or there'll be some sort of tool where you can put it all together. But yeah, things like Unity, they have an asset store. You're like, I need shotgun shell sound files, and you can pull it down and all those asset triggers for you. And then, yeah, generally it's just you load those queues up, and then when you need to do one, you say play queue, and it plays it.
Yeah, makes sense. And chat room, any questions for Chris? Feel free to fire away. I got maybe one more here. How much of these fundamentals that you talked about, the loop and the inputs, how much of that translates one-on-one to VR gamings?
Theoretically, all of them. Because if you think about it, and I'll go back to the game loop real quick. That's just how a program runs. Now, we've created frameworks to hide all of this, but no matter what, this is how a program runs, right?
Yep.
So all of these same tricks exist. Games typically will drop you down to a lower level, even if you're using an engine. It's still slightly lower level than like using Blazor to do a front end, which will hide a lot of this going on inside the web browser and the web browser itself running all of this. But a program runs a line of code when you hit start, and it keeps running until it runs out of instructions. And that's all this is doing. It's just at a very low level. So VR is doing the same principle. It's taking the inputs of the world coming in, whether it's from the network, whether it's from the way you interact, whether it's you interacting with static game objects, keeping track of it, telling the two screens right over your eyes to update accordingly, and continuing as it goes along. It's doing the same stuff.
Yeah, that makes sense. But I mean, I would say like here, the guardrails make a little bit more sense because like what you're doing in those two screens in front of your eyes has a very real impact on the person. And that physics getting off track can have really bad consequences.
Well, I'm going to go to my obligatory find me slide since we're at the end.
Oh, it's a cute swirl.
So typically speaking, I even bought, it's right over there, I can grab it. I bought a 3D monitor because I was playing around with 3D effects back before VR came back into presence. VR is just 3D and hiding. Really, that's all it is. But the idea is the way with our eyes that we get depth and stereo vision and whatnot is the fact that our two eyes are offset. So even if you're looking at something right in front of you, you're still looking at it at an ever so slightly different angle. So within a VR world, and generally speaking, the engine that deals with VR will do this for you, is you say, here's the one camera I pretend like I want to worry about, and it will correctly offset the two cameras and feed in the different information. And it's just like it's got two viewports. So think about if you're playing a split screen game, and so you've got the left side of the screen, your friend's got the right side of the screen, and it's all the same game world that's being controlled, but you've just got two cameras into it, one following player one, one following player two. This is the exact same thing happening in VR. It's just that those cameras are, in terms of the game world, 2-3 inches apart, and they're feeding directly into your eyes. It's the only thing it's doing.
Yeah, well said. It's just like for a lot of us, just getting into game development can be a little intimidating because like there are a lot of tools. I get that, but if you have built regular apps for years and years, just getting in might be the biggest roadblock. Like, but once you get your feet wet, like you're saying, like there is a lot of help around. There are things you can just grab off the shelf and start making things on your own.
Right. And then once you get used to that idea of, oh, this is how that's working, that next lower step down makes more sense. Yep.
Yeah. Makes sense. All right. Any parting thoughts? Anything more about gaming you want to mention? I see all of your contact info. So
all my contact info.
Yeah.
So people who may have been following me for a while, because of the project I just got done with at work, I kind of had to lose my Twitch streams for all. They should be coming back, maybe even one tomorrow, as far as my coding streams. So I'm looking forward to getting back to that again. And once we kind of get the schedule reestablished, I try to like one day a week do some playing around in game stream. So if you're interested, follow me on one of the platforms and keep an eye out for when I do the mono game streams.
Yeah, and you're a freestyle coder pretty much everywhere, so
Pretty much
easy to
everywhere.
easy to find. Yep, and you already mentioned DevSpace conference that's coming up later on in fall. So very cool. All right, and Shmeli, Ork, and others in the chat room, thanks for tuning in. Thanks for asking questions. Yeah, this has been great. And if you need to find Chris, these are all the places where you can go find Chris online. All right, Chris, thank you. Thank you for your time. I know you're like 1 hour behind me. Has dinner already happened, or the family waiting on you?
I will find out when I walk out there.
Me too, because our dinner is right around like 7ish in the evening. So I will find out if the family has been waiting on me or they have already had dinner.
Right.
They know that I'm doing this with you. But all right, Chris, I'm going to bring your screen down. But thank you again for taking a Monday evening, an hour out, and doing this with us. Much appreciated.
My pleasure. Thank you
All
all for
right.
joining me. Thank you all for listening. Again, like you said, here's how to get a hold of me. Oh, actually,
Yep.
that screen's gone. You know how to get a hold of me.
Yeah, I can
If you have
bring
any
that up.
questions,
Yeah, all the places. Yeah, but this is very inspirational. I know you have spent years and years in this world, but just for anybody to start getting into this, there is a lot of help. And once you understand the fundamentals, things like you said start making more sense.
Yep.
All right, folks, I think that is a stream. That is a user group meeting, and we'll see you next month, hopefully on the regular third Mondays, and not like the week before like this month. But take care and be productive, be good, and we'll see you on the next stream. So thank you so much. Yeah, bye.